Hi, everybody. Sorry I can't be there today. I am driving to Wisconsin to pick up my daughter from her outdoor adventures camping trip, which was a total washout, although I think they had a really good time. Anyway, I'll try to make this fast. I'm going to get you finishing the student activity sheet that we did 2 days ago, and then we'll do another one and get them both submitted today. They're both due by midnight, but you should be able to get them done right now. So if you're an in-person learner, you should have checked in the mall. That's where they're taking your attendance. And then everybody else needs to just make sure they've clicked on Canvas by 2:35 today, because that's when I take attendance when I come back from Wisconsin. Okay, so this is what it says. Well, I have to be out. In-person students need to check in. And it says, go to this page to watch my screencast. So I'm going to go ahead and click on the page for today. And today's date is May 20th. And our theme today is, how could trees help stop global warming? So just a quick reminder, we studied last time, we were looking at levels of carbon dioxide in the atmosphere and started wondering how trees could be affecting that. And we saw that levels of carbon dioxide skyrocket in the winter when there's no leaves on our trees. And then in the summer, the levels of carbon dioxide come down again. And so we were wondering what's happening in trees and how could they help us with global warming and what's going on with all these problems we have with our carbon dioxide levels. So that's what we're going to look at today. So the first thing I'll just mention here really quickly, on our page today, I have something, a page that's called the Asian Pride Project. If you're interested in learning about members of our Asian American community and Pacific Islanders who are also members of our LGBTQ community, go ahead and click on that link today. I don't have time because of the screencast. I have to kind of rush us through, but I always want those resources out there that if you're interested, you could take a look. All right, so the next thing I wrote, we need to finish up from last time. We didn't get to watch the last video, and we're going to watch that right now. It's a short one. Oops, I wrote 45 minutes. It's just 45 seconds long. So we'll watch it. We have to write some claims down. So if you haven't already, will you open up your global warming student activity sheet? It was global warming number 1. We didn't get to submit it last time. We'll do that right now. And then we'll open up global warming student activity sheet number 2, which I see I didn't link yet. So give me a second. I'm going to pause it for just a moment, get that linked, and then I'll be right back. All right, magically, I got that linked now. So the global warming number 2 is linked, but let's get number 1 done first. So the first thing that I want to do is to pull up that video. The video, unlike I wrote that it's 45 minutes, is only 45 seconds. So let's take a moment and just watch the 45-second video. You don't need to write anything, just watch the video. Let me refresh the page because it looks like it's stalling out on me. So give me just a second to refresh the page. It's going to take longer to load the video than the video actually is. All right. Can I get it to play full screen?
How tree planting can help reverse climate change. Planting enough trees could be the most effective way to successfully overcome climate change. And it's something we can easily do now by each of us helping to plant a tree a day. Too much carbon dioxide in the atmosphere holds the sun's heat in like a blanket, causing serious changes in global temperatures, which in turn causes extreme weather patterns and ultimately the rising of the oceans. Trees take this carbon dioxide out of the air as they grow. Planting enough trees can restore balance to our atmosphere by converting the excess carbon dioxide into healthy ecosystems and into thousands of useful resources that people need.
All right, so that's all the video is. So now we're going to watch it again.
How tree plant.
Give me a second. But we're going to write down some of those claims. Let me see if I can split my screen. My image went away, but that's okay. We don't need my image to be there. So is this the right one? I need global warming 1 right on. That's the one I'm looking for. All right, so the first thing we need to do is write, in this section, we're trying to rate some of our claims, the claims that were made in the video. I don't care if we do a perfect job on this or not. We're just trying to get some ideas of things that they're claiming in the video that we want to get some evidence for and some understanding, a deeper understanding of. So choose a text box and choose a color other than black, and we'll go ahead and get started. So let me hit play, and I'll just keep pausing it as we go.
Planting can help reverse climate change. Planting enough trees could be the most effective way to successfully overcome climate change.
Okay, so that's our first claim. Planting, whoops. Oh, what did I do? The wrong thing. There we go. Planting enough trees could be the most effective way to combat climate change. I don't know if I quoted that perfectly, but I'll go with that. Hey, before I forget, climate change, you guys, same thing as global warming. It's actually a better term than global warming because not all parts of the planet are seeing temperatures increase. As a planet as a whole, the temperatures are increasing. But any given little area of the planet, their temperature might be going up or down. So we call it climate change. That's a more general term, but it refers to the same thing as global warming. Okay, so that's our first claim. Let's see what other claims she makes here.
Can help reverse climate change.
A little bit too far.
Planting enough trees could be the most effective way to successfully overcome climate change. And it's something we can easily do now by each of us helping to plant a tree a day. Too much carbon dioxide in the atmosphere holds the sun's heat in like a blanket, causing serious changes in global temperatures.
Okay, there's another claim here. So too much, why does that not go away? There we go. Too much CO2, remember that means carbon dioxide. Too much CO2, I'm going to write it down here, leads to changes in global temps. There we go. Couldn't remember what it said. Leads to changes in global temps. Okay, there's a claim. If you have any questions about any of these claims, you're welcome to write them in the column on the next side. So if anything occurs to you, if you're like, what? I don't believe that, or why is that? Those questions go on the next column. Okay, moving on.
Which in turn causes extreme weather patterns.
CO2, so again, high CO2 causes extreme weather patterns. In 45 seconds, they make a lot of claims, right? Let's hear the next one.
Climate change. And it's something we can easily do now by each of us helping to plant. Holds the sun's heat in like a blanket, causing serious changes in global temperatures, which in turn causes extreme weather patterns.
Now the next one.
And ultimately the rising of the oceans.
Okay, going back over here. High CO2 leads to the rising of the oceans because of the melting of polar ice caps. So rising of the oceans. Okay, so there's another claim for you. Let's keep going. Let's see if we can find maybe two more.
Trees take this carbon dioxide out of the air as they grow. Planting enough trees can restore balance to our atmosphere.
Okay, so planting trees. I made it go
by converting the excess carbon dioxide.
Planting trees can restore balance. What does that even mean to our atmosphere? What is balance to our atmosphere? Well, we're going to talk about that today, you guys. We're going to talk about something that's called the carbon cycle and how trees have something to do with the carbon cycle and how that carbon cycle in our planet right now is totally out of balance. All right, let's listen to the last thing she says.
Oxide into healthy ecosystems and into thousands of useful resources that people need.
So you might not have heard that last statement, but she said excess carbon dioxide. So that we're producing that excess carbon dioxide when we burn fossil fuels and that kind of thing can be converted into useful resources. resources. So that's another claim that she makes. And so the question is, what useful resources can we make from our excess carbon dioxide? All right, cuties. So if you have questions or notes or comments about anything that you on this part, go ahead and enter them in there. I read everything that you write. So if there's like something where you're like, hey Jay, I don't understand this, or I don't understand that, or could you explain this? Put those down there. If you leave it blank, that's totally fine. So go ahead right now and just submit. Pause this video if you need to. I'm going to take a moment and close this screen up, and you should be submitting right now. So go ahead and submit this particular assignment. And then I'm going to go over to our page for the day. I'm giving you a moment to submit your assignment. Pause the video, you guys. Just pause the video and submit it. And now I'm going to move on. Okay, so I'm back on our page for today. And let me just say a couple things. So where it says third, it says, now let's talk about the trees. If trees can help stop global warming, how would they do that? That's what we're going to explore today. Let's look at photosynthesis and the carbon cycle. Click here to open our Global Warming 2 student activity sheet. So you need to click on that once you've submitted the other one and open that up. I'll get into that in just a minute. Before we do that, I just want you to take a look at number 4. This is what's coming up in the next few days before summer vacation. We're going to take a look at what's really causing global warming. I've mentioned the burning of fossil fuels, but there's other things. So we're going to look at that next time. We're going to look at who and what are the biggest problems, what's causing the most global warming. And then if the weather holds, we'll move outside one of the days next week, to explore the trees near us. And so if you're an at-home person, you can explore the trees in your neighborhood, or I'll walk with you outside at the high school and you can explore the trees at the high school. So finally, on our last days, there will be a summative. That summative will include a traditional right and wrong test. So I haven't given you a single test this whole year. This one will have a test. And so it'll include things about photosynthesis and cell respiration. We're going to learn about that, the carbon cycle, and global warming. It will also have a written section that'll allow you to do a little bit of research about global warming. So that'll be like on our last day of class before summer vacation. So just giving you a sense of what we're doing. Okay, hopefully that gave you plenty of time to click on your global warming number 2 sheet. And this is the one I need right here. So let's go ahead and take a look and see if we can zip through this quickly. So today we're looking at how trees could stop global warming. What is actually happening inside trees that could stop global warming? Last time we figured out that trees breathe in. Maybe you remember I showed you an image of the little mouths. They're not really mouths, but they look like little lips or something that are on the bottom of a leaf, and they're holes that open up and allow carbon dioxide to go in and allow oxygen to come out. Those are called stomata. So that's what we're going to be talking about today, is what's actually happening inside a leaf that could be helping with global warming. All right, so let's take a look. There are 3 models we're going to look at today. This is model number 1. And question number 1 says, list 3 things entering the leaf in model 1. Again, I'm choosing a color other than black. So we're looking for any arrows that are going into the leaf. So the first one I see is carbon dioxide, and you could write that CO2 if you prefer to do a little bit shorter. Carbon dioxide is going in. I see water is going into the leaf, so that's coming up from the roots. And then I see sunlight is coming into the plant. That's a key to what's called photosynthesis. We need sunlight. The plants need sunlight for photosynthesis to happen. All right, number 2, list 3 substances leaving the leaf. Anyway, so that's arrows that are coming out. So the first one that I see is water that's coming out. Water as a gas. So it's called water vapor. It's coming out. What else is leaving? Oh, I see arrows coming down. So that would be oxygen. And you can abbreviate oxygen O2. That's a good way to do it. And then the last one is a little bit tricky. What else is leaving the leaf? And in that case, it's sugars. Sugars get made in the leaf and then they get transported out of the leaf. So we're going to write sugars. So number 3 says, which substance is both entering and leaving? So we saw that water was going in and we see that water is coming out. This is why plants need lots of water. Water comes in through their roots, but then it accidentally, really, it's accidental, it evaporates out of their leaves. And so they constantly need more water coming in because water is always evaporating out of their leaves. So it's coming in and going out. All right, it says here, in a chemical reaction like photosynthesis, everything before the arrow, here's the arrow in our chemical reaction. Do you see it there? Everything before the arrow is a reactant. They're reacting together to produce everything after the arrow called a product. So question number 4 says, what are the reactants for photosynthesis? So what are the things that are going into a plant in order, or into the reaction for photosynthesis? And here it says carbon dioxide. You can write CO2 if you want. Get into that habit, actually. It's a good thing to be able to go back and forth. Carbon dioxide and water. I didn't need a comma there, did I? So carbon dioxide are the reactants, and then what are the products of photosynthesis? Sugars and oxygen. So I really want you to think about this because it's so important. What are plants making? Sugar and oxygen, you guys. That's really cool. And that's super important for our planet. All right, let's scroll down to model number 2 and take a look at it. It says photosynthesis. By the way, the prefix photo means light. So this is all about light, sunlight coming in and helping these plants do this process. Photosynthesis takes place in leaves in a cell organelle called well, let's study this diagram for a second. So we've got the sunlight here, and this is labeled photosynthesis. Oh, this oval here, it's labeled chloroplast. So that's the name of the organelle that plants have that are doing photosynthesis, chloroplast. Okay, let's look at the diagram again for just a moment more. So I see that it's a cycle. There's arrows going around and around. We're starting in this one organelle that's called a chloroplast, and that's where photosynthesis is happening. I see oxygen being given off, and then I see this arrow coming down, and there's the word glucose. Glucose is a sugar, I'm pretty sure. And here that glucose is going into a different organelle that's called a mitochondrion. Maybe from junior high, you remember the mighty mitochondria. That's where our energy is made. So the glucose is going in. Oh, the oxygen that was given off here, it's coming in here. So we've got glucose and oxygen going into the mitochondrion. We're making a little bit of energy, and then there's some other products that come out of the mitochondrion, carbon dioxide and water, and those go back into the chloroplast. It's like this wacky little cycle. All right, so how does the equation for photosynthesis differ in model 2? So model 1, this was the equation for photosynthesis. And in model 2, this is the equation for photosynthesis. Well, they don't really differ that much. They're very similar. It's just that one is written in words and one is written with the molecular formulas. So model 2 shows the molecular formulas for the reactants and products, whatever, reactants and products. I couldn't think of a good word to write there. Okay, so what is CO2? I think you guys are really good at this one now. I think you've got that one mastered. So CO2, come on, is carbon dioxide. What is C6H12O6? Oh my gosh, that's like the scariest molecule I've ever seen, KJ. What could that possibly be? Well, let's look over here. So CO2, there's 6 carbon dioxides, 6, we know that's water, and some energy, sunlight, makes, that's what the arrow means, it makes C6H12O6 and 6 molecules of water. Let's go back here. What could C6H12O6 be? Sugar. In particular, it's a type of sugar that's called glucose, and you see that right here. So good. What's powering the whole reaction? Well, that's sunlight. We mentioned that earlier. Number 11, based solely on the equation for photosynthesis, give 3 reasons that plants are important for life on Earth. Okay, so what are plants doing that we really care about? Well, for one, today we care about the fact that they're sucking up carbon dioxide. So let's write that down. Oops. They suck up CO2 from the atmosphere. So we're really grateful for that because that helps prevent or limit global warming. Okay, but then what are they making? They're making sugar and oxygen. They make sugar and oxygen, which all life form, well, I'm exaggerating, almost all, let's write almost all to be fair. Almost all life forms, oh my gosh, need. So sugars are food. So you might think, well, KJ, I eat hamburgers. I don't eat plants. But if you eat hamburger, then you're eating a cow. And where did a cow get its food? From plants. So ultimately, it doesn't matter what you're eating. You could be eating a pizza. The food that is in that pizza ultimately came from plants. So all food on this planet comes from plants, and plants are making these sugars from the carbon dioxide that they suck up and the sunlight that powers this whole process. So plants clean our air, give us oxygen, and give us food to eat. Plants are wickedly important. Even if you don't think they're interesting, they're wickedly important. All right, number 12, the thick arrows in model 2, so that's what we're talking about here, are showing a cycle. Look carefully. What is the relationship between the products and reactants of the two reactions, photosynthesis and cell respiration? So I didn't mention that. This process here that happens in the mitochondrion, that's called cell respiration. In this model, they only use the word respiration. I kind of don't like that because respiration is you breathing with your lungs. Cell respiration is what's happening inside each of your 100 trillion cells when glucose and oxygen come in and your body makes the energy it needs called ATP. So that's cell respiration. So what I want you to see, look at this part of the photosynthesis reaction. C6H12O6 plus 6CO2 or 6O2, that's what photosynthesis makes. Look at what cell respiration needs. C6H12O6 and 6 oxygen. What the chloroplast makes is what the mitochondria needs. And what the mitochondria makes is what the chloroplast needs. So they're exactly opposite reactions. So, what is the relationship between the products and reactants? The two processes are opposite. The reactants of one are the products of the other, and vice versa. All right, so then it says study the cell respiration equation. Why do animals need plants? Well, we kind of already said that with number 11 here. Here's cell respiration. In order for us to make our energy, to flex our massive muscles, for our heart to beat, for us to talk, we need glucose, sugar, and oxygen. And remember, when I say sugar, pizza counts because ultimately the way that we made that pizza came from plants. So, like the cheese is milk that came from a cow who ate grass. So, that's all our food that we get ultimately comes from plants. So, number 12, why do animals need plants? Animals need the sugars and oxygen that plants make. Okay, so then it says here plants have both organelles in their cells, chloroplasts and mitochondria. Animals have only mitochondria, but no chloroplasts. Super important idea, definitely on your test. Some people think that plants need animals as much as animals need plants. Is that accurate? Do plants need us? Explain your reasoning. Well, I'm here to tell you, ladies and gentlemen, we need plants because we can't make sugar or oxygen. But plants can make sugar and oxygen, and they have their own mitochondria to make their ATP. So plants are completely what's the word I'm looking for? Self-sufficient. There we go. Plants are completely self-sufficient. They have both organelles. They don't need us. So if animals go extinct, plants will still be just fine. If plants go extinct, animals are gone. So down here, number 14, do animals, so let's see, plants need animals as much as animals need plants. That is utterly false. So that is false. Plants can make their own sugar, oxygen, and energy. They do not need animals, but animals totally need plants. All right, we're on to our last section, you guys. This is Model 3. It's called the carbon cycle. Let's just take a moment to look at the cycle, and then we'll do a little bit of labeling and answering some questions. So the carbon cycle, it says atmospheric CO2. So we're talking about the carbon dioxide that's in the atmosphere. So if you look at D and this arrow, we're talking about something that takes carbon dioxide out of the sky. Oh, look at that, a plant. It's sucking up the carbon dioxide during photosynthesis. So it's removing carbon dioxide from the sky. Notice that all of the other arrows bring carbon dioxide into the sky. Nothing else takes carbon dioxide out of the sky. So respiration is what those mitochondria do. It's when they so if we go back here one more time, here's our mitochondrion. It's releasing or making carbon dioxide. So plants both suck it up and produce some. Animals only produce carbon dioxide. So here's the bunny rabbit making carbon dioxide. And if that's all that was happening in our world, then the carbon cycle would be perfectly in balance. The problem really began when we started industry and started burning fossil fuels. Every single time that we burn something, and that's called combustion when we burn something, whenever we burn anything, it could be a match or a cigarette, or it could be gasoline in our car tank, or it could be a forest fire. Anytime we burn anything, it adds carbon dioxide to the atmosphere. So our planet was really good at balancing the carbon cycle until we started burning fossil fuels. And then that whole cycle got out of balance. All right, so number 15 says, photosynthesis and cell respiration are important parts of the carbon cycle on Earth. Add the label photosynthesis to Model 3 and circle each respiration. So let's go ahead. This one right here, this arrow here is photosynthesis. And then let's go ahead and grab shapes. And I've got a circle here. And so I'm going to circle each one of our respirations. So there's one respiration, here's one respiration, and here's one respiration. So those are 3 different times that cell respiration is adding carbon dioxide into the atmosphere. Number 16 says, I'm going to go back to a text box here. Photosynthesis removes, look at D, it's removing carbon dioxide from the air. Respiration adds carbon dioxide. Which other process adds carbon dioxide to the atmosphere? So where is there an arrow that's also going up that doesn't say respiration? Well, that's this one right here, combustion. So that's our answer, combustion, which is burning. Remember, I'm going to write that so that you remember combustion means burning. Currently, the carbon cycle is out of balance on Earth. Use your prior knowledge to hypothesize about which parts of the carbon cycle are causing the imbalance. Well, there's really 2 things that are going on right now. There are no longer enough trees because we've cut them down or burned them down. And there's too much burning, that's called combustion, of fossil fuels. So what that means is the trees aren't sucking up the carbon dioxide because we cut so many of them down, and we're burning way more. So we've got this excess of carbon dioxide in the air. All right, number 18, burning down the rainforest for agriculture damages the carbon cycle in two ways. What two parts of the cycle are impacted by this one action? So burning the rainforest is especially bad. It's bad enough when we cut the trees down, but when we burn the trees down, that's extra bad. So when the trees are killed, they no longer suck up CO2 during photosynthesis. And burning trees, let's put burning, what does that mean again? That's combustion. Adds CO2 to the atmosphere. Atmosphere. There we go. Okay, so when the trees are killed, they're no longer sucking up the carbon dioxide, and the process of burning the trees is actually adding carbon dioxide. Anytime we burn anything, adds carbon dioxide to the atmosphere. Okay, cuties, we are down to our very last one. Carbon dioxide, CO2, is one of the so-called greenhouse gases. We're going to learn about other ones. These gases hold heat energy in the atmosphere like a blanket holds on to body heat, which raises the overall temperature of the earth. Let me just say this really quickly. When you have a blanket on your bed and you're in your bed and you have a blanket on you, the blanket itself isn't warm, right? It's the same temperature as your room. But why do you get warmer when you put the blanket on you? The reason you get warmer isn't that the blanket got warmer. It can't get warmer. It's just a blanket. The reason you feel warmer is that your body heat is trapped by the blanket and your body heat isn't escaping into your room. If you take the blanket off, then your body heat escapes and you feel cooler. If you put the blanket back on, your body heat can't escape and so it feels warmer. Well, that's what carbon dioxide and other greenhouse gases are doing. They're like a blanket. So when the earth gets heated up by the sun, the planet warms. And then as the planet rotates away from the sun, the heat is supposed to escape into the universe. And that's supposed to cool the planet down at night. The problem with all the carbon dioxide in the air is that it's like the planet is wearing a blanket. So when it rotates away every night, when it rotates away from the sun, not as much of the heat escapes. And so gradually the entire planet is getting warmer and warmer and warmer. And this blanket is getting thicker and thicker. So let's see, I didn't quite finish this one. So some carbon dioxide in the atmosphere is an important part of Earth's biosphere. So it's okay to have some, for sure, some carbon dioxide in the atmosphere. Plants need carbon dioxide. However, as CO2 levels rise, so does the average temperature of the planet. In the last video we watched, the following claim was made. Planting enough trees could be the most effective way to successfully overcome climate change. Using evidence from models 1 through 3 support that claim. So let's make sure we have a sense of what we're doing here. Photosynthesis is the process of sucking up carbon dioxide, and that turns it into good things for us. It turns it into sugars and oxygen. And then carbon dioxide is the thing that's heating the planet. So if we're sucking carbon dioxide out, we're going to control climate change. So let's just see if we can write that down here. So photosynthesis is the process where plants suck up the CO2 that is acting like a blanket and keeping the planet warm. Okay, so photosynthesis is the process where plants suck up the carbon dioxide that is acting like a blanket and keeping the planet warm. The less CO2 there is, the less global warming. I don't know, this is getting awkward now. Plants use the CO2 to make great things. And then what we learned today, they make sugar and oxygen. All right, cuties, that is it. Go ahead and hit submit. You are all done for the day, and I hope that you have a fabulous weekend. Go see Ms. Sampson tomorrow. Friday is a B day. No, Friday is an A day. Sorry, I didn't say that right. Friday is an A day. Have a great day. See ya.